Yes, electrical chemistry. Okay, and here we are going to start this topic one. And the subtopic is first okay. So this is the subtopic. So this topic relates to writing the chemical equations. Means its heading is the main thing that we are going to study is the writing the chemical equations. All the requirements for writing the chemical equations. Okay. So actually, for writing the chemical equation, we must know that what is the chemical equation. Actually, chemical equation to represent or is used to show any chemical reaction. Means suppose when someone says that carbon reacted with oxygen to form the carbon dioxide, carbon reacted with oxygen and form the carbon dioxide, then how would you present? So we take the help of the carbon, get reacted with oxygen to form carbon dioxide. Okay. So these things are called reactants. What we call them? Reactants. And these are called products. Okay. They can be 1, 2, 3, depending on the situation. Okay. It's not necessary that the reactants will be more or the products are more. Okay. It's not necessary. Okay. So means they can be different. The numbers can vary. So what is important that we need to know first for writing the chemical equation? Actually, chemical equation to represent the chemical equation, chemical reaction. Okay. So very important thing that we need to know first symbols or formulas. What are the symbols? Symbols to represent elements. Okay. If any element is taking part in chemical reaction, then we will use the symbol. But if there is any compound, then we have to use the formula. Suppose compound can be, we know that there are some very famous organic compounds, that can lead, you can say covalent compounds, suppose H2O, water, carbon dioxide, okay, and sulfur dioxide, etc. These are very famous, and there are a few, ammonia and H3, okay. So we can memorize them. But for writing the ionic compounds, which in which we are mostly concerned about them, okay. So ionic compounds, actually ionic compounds are those in which charges has to be balanced, okay. It has to be neutral, balanced charges. Suppose if I write NaCl, so it has Na plus and Cl minus, means both have plus or minus one charge, so neutral it will be, okay. Mainly it will be the neutral. If we have Mg, okay, and then its formula is MgCl2. How would we get its formula? That is the next step, that we need to know their charges, and that is a method which is known as cross exchange method. You must have studied in O levels. Cross exchange method, in which what we do, we write first cation is plus charge, Na plus, then we write anion with the negative charge. Suppose we are writing here oxygen minus 2 charge, sodium oxide we want to do. We bring the write down corner of the other element. Okay, this is a cross exchange method. Okay. It has 2, without charge we will bring it here 2. It has plus 1, so without charge we will bring it here 1. So it will become Na2O, sodium oxide. Okay. So I am writing here some more examples. Suppose you have Mg. How did we get MgCl2? Let's see. And this is the chlorine. It has minus charge, it has plus 2 charge. This is clear. So bring it down. Okay. 1 and 2. So it becomes MgCl2. Is it clear? So in this way we get one more example, just for your information, that aluminum oxide. Aluminum, it has plus 3 charge. Oxygen, it has minus 2 charge. want to make its formula, that what will be the formula of aluminum oxide, we have written the aluminum that mostly forms the cations because it always forms cations because it is a metal. And oxygen is non-metal, it will gain electrons, it will become anion. So cation we write on the left side and anion on the right side, and with their charges. Now without their charges we bring right bottom of other element, okay, without charges, just will bring the figure 3 and 2. It will become Al2, Al2, O3. In this way, they have equal positive and negative charges, and this compound will be neutral. Okay, so these are the neutral compounds. Is it clear? So, what we are studying that for writing the equation, we need to know the formulas, okay, and the symbols. Symbols are given in the periodic table, okay, periodic table. So we can take from there, and the formulas then we can take. Okay. So we can take it out like this. The next thing that we need to know, a writing equation. Okay, a writing equation. Suppose you have in given description, someone says that iron oxide, iron 3 oxide. Okay, this is a writing equation from the description. Reacts with the carbon monoxide. Okay, carbon monoxide to form iron and carbon dioxide. So how would we write? Iron 3 oxide, how would we get its formula? Fe3 shows me it has plus 3 charge, okay? Oxygen has minus 2 charge, okay? 2 and 3 becomes Fe2O3. Fe2O3 will write the carbon monoxide CO. Okay. Then we get iron Fe and get carbon dioxide CO2. This is writing the equation from the, okay, and how can we balance it? First I'm writing it balanced, and next I will tell you that how can we make it balanced. Okay, so this is the balanced chemical equation, but what is to write? It is to write the iron oxide, okay, and then we need to write the carbon monoxide, and then we wrote the iron, and then we wrote the carbon dioxide. Is it clear? How we balance it? Now let's see. I'm going to write one more equation. Suppose from writing from the description, someone says decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. So how would we write? H2O2 to form water and oxygen. So we know that H2O is the water, H2O, and oxygen is always in O2 form. So how can we balance it? One oxygen this and two this, it becomes 3, and we have only 2. So if I write here 2, okay, so 2 twos are 4 oxygen are here, so there is 2 oxygen here, and 1 this. If I write here 2, so 2 ones are 2 and 1 twos are 2. In this way, 2 oxygen with the water and 2 oxygen atom in the oxygen molecule, okay, and it becomes 4, and on this side we also have the 4, okay. So this is the decomposition of hydrogen peroxide into the water and the oxygen. Okay. So this is writing the equation from the description. Now how can we balance them? Balancing, it has some steps. First we need to write the reactants, okay, and products. First step. Second step, we need to count atoms on both sides of each element. If those are not balanced, if not equal, if those are not equal, then we need to use coefficients. Suppose I'm writing here one equation, the same equation which we wrote. Fe2 iron oxide, Fe2O3 reacts with the carbon monoxide to form, carbon monoxide, not carbon dioxide. We get iron and then we get carbon dioxide. Once again, that I forgot to write carbon monoxide. Okay. And then we get carbon dioxide. So now it is important that how can we balance it? If you look here carefully, that we have how many iron? Fe2. But here we have only one iron, so I am writing here 2. So 2 iron here and 2 iron there. Okay, now it is balanced. Now let's talk about the oxygen. Carbon dioxide, it takes one oxygen. Carbon monoxide, it will take one more oxygen to become carbon dioxide. But there are 3 more oxygens, so we will need 3 more carbon monoxide to take each one oxygen from the iron oxide, and each will convert into 3 carbon dioxide. So if I write here 3, so it means all these 3 carbon monoxide are taking one oxygen for each, and it will become 3 carbon dioxide. If we check it once more, Fe2 to Fe, 2 1s are 1. It's okay. Fe is balanced. Oxygen, how many oxygen we have? 1 3s are 3 and 3 1s are 3. 3 multiply 1 3 and 1 multiply 3 3. So it becomes 6. So 3 2s are 6. 3 multiply 2 6. How many carbon there? 3 1s are here. We have not written, but if we don't write here 1, so it doesn't mean that there is one atom. Okay, 3 1s are 3, so 3 1s are 3. So in this way, first we need to write the reactants and products, and for writing the reactants and products we need to know the symbols and formulas accurately. Okay, symbols and formulas. So we have already studied in the same lecture that what are the methods for writing these formulas. Okay, so then we need to count the atoms on the both sides of the equation. Okay, so after counting, if not equal, then use the coefficients. Okay, coefficients means these things, we change them. Okay, we don't have to change the formulas. We can't say CO2 means we can't make it carbon dioxide CO3. It won't be carbon dioxide. Okay, it will be ridiculous. Okay, we can't make Fe2 because it does not exist as the molecular form. It exists as the atomic form. So that's why we need to know that how to write the balanced chemical equation. So this is a step that writing the balanced chemical equation. So these are the 3 steps. So let's take one more example. Water, H2 plus O2. Why we are writing H2 and O2? Because we have been told that hydrogen reacts with oxygen to form the water. This is the description. Hydrogen reacts with the oxygen. So reacts means these both of them are the reactants. Okay. To form means the next thing. To form the water. Water is H2. How hydrogen exists in the nature? It exists in the its state in molecular state in H2. And oxygen, how it exists? It also exists in the O2 form. It cannot exist in simple oxygen form. It always exists in the atomic molecule as diatomic molecule. Okay, having the double bond with each other, and hydrogen having the single bond with each other. They are very reactive. Hydrogen cannot exist as it is because they have to complete its duplet or octet. So that's it completes its octet. It completes its duplet by sharing with the same type of the atoms. Okay, their electrons, and in this way its duplet, their duplets are complete and their octets are complete. Okay, so they cannot exist individually in the atomic form. They always exist in the molecular form. Okay, so that's why I've written here H2 and O. So, but here you can see that two hydrogen, and this is the water H2O. You can see that we have two hydrogen. That's okay. We have two hydrogen. We have one oxygen, but here is we have sorry one two are two oxygen, and here is one oxygen. So two oxygen and one oxygen. Here is the problem. So we need to balance them. So for writing balanced chemical equation, I change the coefficients. The third is latent products. We already have written count the atoms. We counted the atoms. If not equal, then use the coefficients. Now we are using the coefficients to make the balanced oxygen. I am writing here two. Two ones are two oxygen. But here the hydrogen has also been multiplied with a 2, has also been increased to 2s are 4. So I need to write here back. Okay. This is writing the balance calculation. But one more thing is writing the state symbols. There are three states: solid, liquid, gases, and aqueous. When something is soluble and will dissolve in the water, so it becomes aqueous. Solid we write here as subscript S. Downward at the bottom of the any symbol or formula we write S. In the same way as subscript we write small l to show that substance is liquid. If that is the gas we write small g. If that is aqueous then we write aqueous. Suppose hydrogen we have this gas. Oxygen then this is also gas. Water we get in the liquid form. Is it clear? At the room temperature. Fe2O3 that is the you can also the formula of questioning. So it is in the form of solid. Carbon monoxide is well known gas. We get iron because we provide here heat. So that's why iron won't be in the form of the solid. It will be in the liquid form, in the molten form. Okay, molten form. And then we next get carbon dioxide. That will be definitely gas. Make sure that we can't write H2O aqueous because this is the liquid. Aqueous we write when some solute dissolves in the liquid. Okay. Which liquid in water. Suppose we have NaCl and when we dissolve in the water, so it will become aqueous solution of NaCl. We will write AQ. Otherwise, it was to exist in the solid form. NaCl is in the solid. So here's the difference between the aqueous and the liquid form. Liquid means simply that exists as a liquid. Okay. And aqueous when we add something into the water. Okay. So the solution is formed that is called aqueous solution. But for some reactions, we don't write the state symbols like the organic reactions. For the organic reactions, sometimes we don't write, mostly we don't write the state symbols. And for ionization reactions, means if we have change of electrons or addition of electrons or you can say elimination of electrons. So for ionization equation, we don't write the symbols. Suppose we have Na, so it loses electrons to become Na plus, and it loses electrons. So here we don't need to write which type of state is there. Actually, it is in the gaseous state. Okay, but we mostly leave it, and it's not as important as to write in the ionic equation. Okay. Here is given some description. Now let's see the we have to practice. That aqueous solution of sodium nitrate, sorry, silver nitrate, silver Ag, nitrate NO3, and aqueous solution means it is soluble in the water. Aqueous solution of silver nitrate is reacted with the aqueous solution of calcium chloride means we have CaCl2, calcium chloride. Okay, and its aqueous solution means AQ are reacted to form insoluble or you can say precipitate of AgCl, and that is insoluble means it will be in the solid form. Even if it goes into the solution, but it will not dissolve. It will settle down and it will be as precipitate. This type of reaction is called precipitation reaction. And we get the calcium nitrate solution. CaNO3 twice. This is aqueous solution. So now let's see. Here we have Ag1, Ag1. We have NO3 one, but here is NO3 twice, two times. To balance it, I am writing here 2. When NO3 has been written twice, it has been balanced, but Ag has also been doubled. To balance it, I am writing here 2. Okay, now let's start once again. Ag 2 times. So here Ag 2 times. NO3 means it is 1 time, and 1 we write in the start. 2 means we are changing the coefficients to make it balanced. So here is also twice. Okay. So Ag and NO3 nitrate ions both are equal. Calcium 1 times. It's okay 1 times. And 1 multiplied 2 means 2 times chlorine, and 2 multiplied 1 2 times chlorine. So now you can say this is the balanced chemical equation, and we have written this equation with their state symbols from the description. In the description, state symbols are mentioned, means are told, means aqueous solution is formed and that gas is formed. Okay, so in the same way, I'm writing here once more. Hydrogen gas reacts with the oxygen gas to form a liquid water. To form water, if they only tell about the water, then we will take it in the liquid form. Okay. So now to balance it, 2 oxygen here, there is only 1 oxygen. I write here 2. This hydrogen is already balanced H2. But oxygen 1 time here is 2 time, here is 1 time. So to balance it, I write here 2. I can't change the formula. I can't write H2O, it is 1 time, so balance it. No, it will become something else. It will be hydrogen peroxide. So I have to just change the coefficients if the number of atoms are not equal. So I've changed 2 times to oxygen balance, but hydrogen has also been doubled. So for writing here, I use the coefficients. So for today it's enough, but actually one more thing is left. The main thing of this topic is left, that is what we call it, balancing or writing the ionic equations. Let's start it, let's discuss it, okay, to finish this topic. For writing the ionic equation, first is write balanced chemical equation. Balanced chemical equation, which you have studied. It is the first step. Second is break into ions. Which one? With which we write AQ. Those with the solid, the liquid, with the gas, they do not break into ions. Do not break into ions. One more thing. If we have diatomic gases, means O2, Cl2, so these are also diatomic gases, and these are also gases, so they will not break down into ions. Third thing is cancel the spectator ions. The ions which are same on the both sides, we will cancel them. Write the remaining equation. Sorry, we can say rewrite the remaining equation, and that remaining equation will be the balanced ionic equation. Okay, so let's start. I am here with your previous task. We were given an equation AgNO3. AgNO3. It reacts with the calcium chloride, and we get AgCl, and next is calcium nitrate is formed. Here we need to know their state symbols. It's aqueous. Their state symbols will make it clear that whether we have to break into ions or not. Now let's break them. Aqueous means Ag. It's to make it balanced 2Ag, 2AgCl. It's okay. It's balanced. We have already done that, how to make it balanced. Okay. Ag has two, so two ions of Ag will be formed. And those will be aqueous. Same, two nitrate ions will be formed, NO3 minus, it will be aqueous. Plus calcium plus 2 ion will be formed, but it will be also aqueous in the water. It will be. Two chloride ions will be formed, those will also be aqueous. But this 2AgCl will remain as it because it is a solid. It will not break down. It is insoluble. It will not decompose into its ions. It will not convert into its ions. Next is calcium, Ca plus 2. So it is also aqueous form. 2NO3 minus is also in the aqueous form. This second step we have done. Write the balanced chemical equation. We have written, break them into ions, aqueous. And if there is solid liquid and gas, do not break into the ions. Okay, we can break into the ions, and we have done. Cancel the spectator ions which are not taking part, which remain unchanged on the both sides of the equation. So we call them spectator ions, which do not change. So if you see that calcium, okay, if you see then calcium remains same. NO3, 2NO3, and here we also do NO3. What is left? The remaining 2Ag aqueous plus charge and 2Cl minus aqueous will react to form 2AgCl solid. So this is the ionic. Okay, take care, and you need to do more practice by using the worksheets to be sure these concepts are mostly related to what you have studied in O levels. Okay, but we need to improve them, and we need to have one of our. Take care. Goodbye.